Greetings. In the previous lecture, we have studied beta functions and the examples based on beta functions. Now, the next topic is differentiation under integral sign, or in the short form DUIS. Now, again, this method is used to simplify the integrals. So, some particular type of integrals can be solved using differentiation under integral sign. As the name clearly suggests, it is the derivative of the integrals. It is under integration we have to consider the differentiation. Basically, there are two types of DUIS rules are there. These rules are defined by the scientist Leibniz. Hence, these are called as Leibniz rule. So, we'll start with the topic DUIS. Now, Leibniz rule number 1. Suppose we consider integration a to b f of x alpha dx. Now, in this integration, there are four terms. One is x, alpha, a and b. A and b are constants where x is the variable of integration. So, this integration is also dependent on the alpha, but actually it is not the variable. So, such type of alpha is called as a parameter. So, this is a parametric integral. So, integration of the form a to b f of x alpha dx, where a and b are constants. Hence, we denote it by I of alpha. So, we consider the integration I of alpha as integration a to b f of x alpha dx. As we have seen, alpha is a parameter. So, Leibniz rule states that we can differentiate this integration with respect to alpha, and it is given by I dash of alpha equal to integration a to b dabba by dabba alpha of f of x alpha dx. It is partial derivative of f of x alpha with respect to alpha under the integral sign a to b f of x alpha dx. So, if I of alpha equal to integration a to b f of x alpha dx, then I dash of alpha equal to integration a to b dabba by dabba alpha of f of x alpha dx. Note that in this first rule, a and b are constant terms, or constants we can say. They does not depend on the parameter alpha. So, the second rule is for the limits which are not constants, but these are functions of alpha. So, suppose we consider function or I of alpha equal to integration a to b f of x alpha dx. Now, what is the change in this? Earlier, a and b were constants. Here, a and b are functions of alpha, and alpha is our parameter. Then, the Leibniz rule number 2 says that, or defined as, I dash of alpha equal to integration a to b dabba by dabba alpha of f of x alpha dx plus f of b alpha db by d alpha minus f of a alpha dA by d alpha. If you observe the right hand side term, the first term is same as in Leibniz rule. Additionally, we get two terms. The second term is obtained by substituting x equal to b in f of x alpha and differentiating b with respect to alpha minus f of a alpha into dA by d alpha. So, these are the two rules which we are going to use to solve the examples of DUIs. Let us solve some examples. Before we solve, we can note one thing, that these parameters can be one or more. So, if only one parameter is there, there is no problem. But if more number of parameters are containing in an example, then we have to choose one of them as a parameter and the remaining term as a constant. So we'll solve some examples based on Leibniz rule. First example, prove that integration 0 to 1 x raised to a minus x raised to b divided by log x dx equal to log of a plus 1 upon b plus 1. If you observe this integration containing three terms a, b and x. Clearly x is a integrating variable, a and b are the parameters. Out of this we have to choose one as parameter and remaining as a constant. As the integration value is log of a plus 1 upon b plus 1, we can solve this problem using DUIS. So if you observe the left hand side, as we have said, there are two constants. One is a and b. Out of these two, we have to consider one is parameter and another one is constant. Okay, so you can choose either a as a parameter or b as a parameter and the rest as constant. Suppose we consider a as a parameter and let I of a equal to integration 0 to 1 x raised to a minus x raised to b upon log x dx. So we will differentiate this using the rule of Leibniz. So if you observe the limits are 0 to 1, that means both the limits are constants. So we have to use Leibniz rule number 1. So differentiating this integration I of a with respect to a using Leibniz rule number 1. So we get I dash of a, as left hand side is only containing one variable a, so differentiation will be ordinary I dash of a, or it is also given by di upon a, not dabba in the left hand side. So using the first Leibniz rule, we get integration 0 to 1 dabba by dabba a of x raised to a minus x raised to b upon log x dx. So this term we are differentiating with respect to a, where b is constant as well as x is constant, because we are differentiating partially with respect to a. So the derivative of x raised to a with respect to a will be x raised to a into log x, whereas derivative of x raised to b is 0. So this integration equal to integration 0 to 1 x raised to a into log x minus 0 upon log x. So log x it cancel, we get integration 0 to 1 x raised to a dx. Hence solving this, integration of x raised to a is x raised to a plus 1 upon a plus 1 from 0 to 1. So substituting upper and lower limit, we get 1 upon a plus 1. So we get the value of I dash of a, but we are not interested in finding I dash of a, we are interested in finding I of a. So we will integrate this term with respect to a. So integration of I dash of a will be I of a, and integration of 1 upon a plus 1 will be log of a plus 1. As we are taking indefinite integration, so c is the constant of integration we will add. Therefore we get I of a equal to log of a plus 1 plus c. We will call this equation number 1. As we have considered I of a as integration 0 to 1 x raised to a minus x raised to b upon log x dx. So we have to find the value of c. So we have to choose a as some number such that this integration becomes 0. So if you observe the term in integration, it is x raised to a minus x raised to b. So if you put a equal to b, we get integration equal to 0. So let's put a equal to b. Therefore LHS will be I of b and RHS will be 0. So I of b equal to 0. Similarly, from equation number 1, we will get I of b equal to log of b plus 1 but plus c. But I of b is 0. Substituting that value, we get 0 equal to log of b plus 1 plus c. Therefore c equal to minus log of b plus 1. So substituting this value in equation number 1, we get I of a equal to log of a plus 1 minus log of b plus 1. But log of a plus 1 minus log of b plus 1 is log of a plus 1 upon b plus 1. And replacing I of a, we get integration 0 to 1 x raised to a minus x raised to b upon log x dx equal to log of a plus 1. Hence the proof. So in this problem we have considered a as parameter. You can choose b as parameter also. Then also you will get the same answer. So the procedure is, whenever we want to use DUIS, we have to check which rule is going to be used, whether rule number 1 or rule number 2. In rule number 1, if the limits are constants, we will use rule number 1, otherwise rule number 2. Let us solve one more example of DUIS. Rule number 1. Prove that integration 0 to infinity e raised to minus x minus e raised to minus bx upon x dx equal to log of b upon a. Again, this integration consists of three terms, x, a and b. X is term of integration, so a and b are the parameters. As integration value is equal to log of b upon that depends on this parameter, hence we can use DUIS to find the integration. Again, observing the limits are from 0 to infinity, that means both the limits are constant, hence we will use rule number 1 to solve this. So again there are two parameters a and b. We can choose one of them as parameter and one of them as constant. So for simplicity we consider a as parameter, b as constant. Let I of a equal to integration 0 to infinity e raised to minus ax minus e raised to minus bx upon x dx. So let us differentiate I of a with respect to a using Leibniz rule number 1. Therefore, in LHS we get I dash of a equal to integration 0 to infinity as it is dabba by dabba a of e raised to minus ax minus e raised to minus bx upon x dx. Again, x and b are constant with respect to a, so second term का derivative 0 होगा. The derivative of e raised to minus ax with respect to a will be e raised to minus ax into minus x. So x is cancelled and we get integration 0 to infinity e raised to minus x into minus 1. Sorry, that minus should be there. So integration will be e raised to minus x upon minus a from 0 to infinity. Therefore, if we substitute the value, we get this equal to 1 upon a. So I dash of a equal to 1 upon a. Again, we want to calculate I of a. So integrating with respect to a, we will get I of a equal to log a plus c. Again, from equation number 1, we will call this equation number 1. Since I of a equal to integration 0 to infinity e raised to minus ax minus e raised to minus bx upon x dx. Hence, we will choose a equal to b because we want the integration as 0. So if we put a equal to b, integration becomes 0. Therefore, I of b equal to 0. So from equation number 1, I of b will be log b plus c. Therefore, c is equal to minus log b. So if we replace this value, we get log a minus log b. Therefore, the value of integration will be log of a upon b. Just one mistake is there. In the previous term, if you observe here, it should be minus sign. This minus sign will carry in each step. So make a correction that I of a will be minus log a. Hence, c will be log b. And if you correct this mistake, you will get I of a equal to integration 0 to infinity e raised to minus ax upon minus e raised to minus bx upon x dx equal to log b upon. Just correct that mistake. That should be minus times the integration. You will get the correct answer. Thank you very much. In the next part, we will solve the examples of DUIs using Leibniz rule number